Hello and welcome to this Python tutorial. So in the previous tutorial, we plotted our dendrogram and we used it to find the optimal number of clusters, which was 5 clusters. And now, since we have the right number of clusters, we are ready to move on to the next step, which is to fit our hierarchical clustering algorithm to our data with the right number of clusters, 5 clusters. So again, this third step of hierarchical clustering is the exact same third step as in k-means clustering. Okay, so now let's introduce a new section with the comment fitting hierarchical clustering to the mall dataset. Okay, so the first thing that we have to do is to import the right tool that is going to help us to fit the hierarchical clustering algorithm to our data X. Remember that in k-means, this tool was the k-means class, and here it's going to be the same. We are going to use a hierarchical clustering class to fit hierarchical clustering to our data in a flashlight. Okay, so what is this class going to be? Remember in the intuition section, Kirill talked about two algorithms for hierarchical clustering. One is agglomerative hierarchical clustering, and the other one is divisive hierarchical clustering. He also said that the most common one was agglomerative clustering, so the class that we're going to import right now to fit hierarchical clustering to our mall dataset is going to be the agglomerative clustering class from the awesome scikit-learn. Therefore, let's import this class. So we write from sklearn.cluster import agglomerative clustering. Remember the k-means class was with a capital K and capital M. Well, here it's the same, it's capital A and capital C. Okay, and now we are ready to fit the hierarchical clustering, that is the agglomerative hierarchical clustering, to our data X. And same as k-means, we start by creating an object of the class agglomerative clustering. So we type HC equals agglomerative clustering. And now in this object, in parentheses, we are going to specify the different parameters. So the first parameter is n clusters, the number of clusters, which now we know is 5. So we type n clusters equals 5. Then the second parameter is affinity, which is actually the distance to do the linkage. And as usual, we're going to choose the Euclidean distance. So we add the second parameter, affinity equals Euclidean. And finally, the last parameter and the most important one is the linkage. So we're going to use the same linkage as the one we used when we built our dendrogram, which, as you remember, is the Ward linkage, the Ward method, which I remind is a method that is trying to minimize the variance in each of the clusters. Okay, so by writing this line, we just prepared the hierarchical clustering algorithm because, as you notice, we haven't input our data X yet. So we haven't fit the hierarchical clustering algorithm to our data X. However, we are going to do just that right now. So let's write a new line of code. And in this line of code, we're going to fit the hierarchical clustering algorithm to our data X while creating the clusters vector, that is the vector that tells for each customer which cluster the customer belongs to. So we're going to call this vector y underscore hc, then equals, then we take our object hc that contains the agglomerative clustering algorithm ready with the correct numbers of clusters, 5 clusters, the Euclidean distance, and the word linkage. And now, same as k-means class that contains the fitPredict method, the agglomerative clustering class also contains the fitPredict method, and so we add here dot fit underscore predict, that is the fitPredict method that is going to return the vector of clusters, and then in parentheses x, to of course specify that we are fitting the agglomerative clustering algorithm to our data X, and that we're predicting the clusters of customers of our data X. So basically, we just did exactly the same as in k-means. The only difference is the class that we use, which is here agglomerative clustering instead of k-means. Great, so we are done with the fitting section. So let's select this code section here and execute it. Alright, and now we can see that in Variable Explorer, this new vector of clusters YHC appeared. So let's double click on it. And let's also open the dataset to see the associations. So the first customer ID number 1, belongs to cluster 4. Then customer ID number 44 belongs to cluster 1. And our last customer, the customer ID number 200, belongs to cluster 2. Alright, so we are done with this new step of fitting the hierarchical clustering algorithm to our data X. So that means that we did a great job. We can actually be proud of all our achievements. And so now we deserve to have a little fun, which is exactly what we are going to get in the next step. So I look forward to seeing you in the next tutorial, and until then, happy